Hello everyone. Today we're going to look at how to solve quadratic equations by taking square roots. Now first we're going to examine a couple of graphs of quadratic equations. So in this first one we have x squared is equal to 16. On the graph you'll see the graph of the quadratic function of x squared. That is your parent function. So we have the points 0, 0, 1, 1, and negative 1, 1. Now then we have the horizontal line at at y is equal to 16. In order to find the solutions from graphing, just like with absolute value functions, our solutions are when the quadratic, the parabola, is intersecting that horizontal line. So we'll see those points of intersection here and here. And when we get those x values, we get that x is equal to negative 4 and positive 4. Now, if I were to solve this by taking square roots, we have the equation x squared is equal to 16. Now, whenever you square root something, because we need to solve for x, you would get x is equal to plus or minus 4. And we say plus or minus because when you square root a number, so such as 16, the two numbers that multiply to give you 16 are 4 and 4. Additionally, we can also multiply negative 4 and also get 16, which is why anytime that you square root a number, your answer is both the positive and the negative. So if we examine the graph and we solve by taking square roots, you see that you get the same answer. Now, if I were to try to solve x squared is equal to 5, here we have the equation for x squared, so the parabola, and then we have the horizontal line at y is equal to 5. If I try to find those points of intersection, we see that it is not at an exact number. It's approximately 2 point something, since it's after 2, and negative 2 point something. So in a case like this, right, graphing may only give us approximate answers, not exact answers. So this kind of equation, x squared is equal to 5, is easier to solve, or rather more precise to solve, by taking the square roots. So if I were to take x squared is equal to 5 and solve that, I would square root both sides, and I would get x is equal to plus or minus the square root of 5. And this is the most precise answer. If you were to put the square root of 5 in a calculator, and I'll show you what that would give you now. Here's the square root of 5, which is 2.236, etc., etc. So we see that it is a little bit after 2 and negative 2. Now, when we're solving square roots, we're going to have to deal with radicals a little bit. So we're going to practice. Now, we have two properties here to keep in mind when we're working with square roots. Okay, when you square root to some number a times b, we can separate that to be the square root of a times the square root of b. Now, how this helps us is when we're trying to simplify a square root. So here we have the example, the square root of 12, which the square root of 12 is equal to the square root of 4 times 3. And so if I separate that, I get the square root of 4 times the square root of 3. Now I know what the square root of 4 is, which is 2. So you get 2 times the square root of 3. So that is a simplified version of your square root. Now when you are dividing, so when you have a fraction inside of a square root, remember fractions are division, we can separate those fractions. And we can do the square root of the numerator divided by the square root of the denominator. So in this example, we have the square root of 5 over 9. Now I don't know the square root of 5, so we can keep it as the square root of 5. But the square root of 9 is 3, and so this would be the simplified version of the square root of 5 over 9. Now let's practice using these properties. For the square root of 75. Okay, this is just like the square root of 12 situation, where we break down into the numbers. Now I write it a little bit differently, and I use this analogy when we're trying to simplify square roots. Think of your square root as a house, and in your house you have a strict household, where your mother does not let you out unless you leave with a friend. So what we're going to do is we're going to try to find friends. Now, friends in our numbers are numbers that are the same. So as long as you have a partner, you are able to leave that square root, meaning leave the house. So Let's try to break this down. 75 is when you multiply 25 and 3. And then 25 is 5 and 5. Here are friends. But this 3 does not have a friend. It's all alone. And I cannot break it down anymore because the only two numbers that multiply to give you 3 are 1 and 3. So therefore, when I rewrite this radical, it would be 5 square root of 3, since the 5 gets to go outside, but the 3 has to stay inside. Now the square root of 28 over the square root of 9. The square root of 28 over 9 is the same thing as saying the square root of 8 over the square root of 9. Now I don't know what the square root of 28 is, but I do know the square root of 9, which is 3. So right now, this is what I have. Now, whenever you are working with square roots, you always want to try to simplify the square root as much as possible. So let's see if I can simplify the square root of 28. If I break down 28, 28 is when you multiply 4 and 7. 4 can be broken down further to 2 and 2. So here we have some friends. Now the only two numbers that multiply to give you 7 are 1 and 7. So 7 has to stay inside. So I can rewrite the square root of 28 as 2 square root of 7. And we're going to put it over 3. And that is the square root of 28 over 9 simplified. Now for the square root of 2 over 7, we can separate this just like before. So the square root of 2 over the square root of 7. Now there is no such thing as a square root of 2, and there's no such thing as a square root of 7. So this would basically be my answer. However, we cannot have a square root in the denominator. And the reason for that is fractions are parts of a whole. And if I were to take the square root of 7, so you can see here, square root 7, we get 2.64, etc. Okay, this is not a whole number, and the denominator has to be a whole number. So in order to make this denominator a whole, right, what we're going to do is called rationalizing the denominator. And that's because the square root of 7 is an irrational number. So we want to make it rational. And how you do that is by simply taking whatever is in the denominator and we're going to multiply it to the numerator and the denominator. When you are multiplying, remember this is like working backwards. The square root of 4 times the square root of 3 is the square root of 12. So if I have the square root of 2 times the square root of 7, that is the square root of 14. Over the square root of 7 times the square root of 7 is the square root of 49. But I know the square root of 49, and the square root of 49 is 7. So this is the way that I would rewrite the square root of 2 over 7. Now, just as a side note, whenever you have two square roots that are multiplied with each other, and they have the same number inside, what happens is that the square roots just cancel because you're taking 7 times 7, so that's a pair. So you're leaving that 7 outside of the radical. Now let's look at how to solve a couple of square root equations, some quadratic equations. Whenever you're solving a quadratic equation, you want to get that x all by itself. So you have to move things over to the right side. So for example, for 2x squared minus 16 is equal to 0, I'm going to add the 16 over to the other side. And I get 2x squared is equal to 16. Then I would divide by 2. And I get x squared is equal to 8. Your last step is to square root both sides. So x is equal to plus or minus the square root of 8. But remember, we ended up with a square root, so we want to see if we can simplify this. 8 is broken down to 4 and 2. And 4 can be further broken down to 2 and 2. So here's a pair, and this 2 is by itself. Therefore, I can rewrite my final answer as x equals plus or minus the 2 that has to stay, this 2 that gets to go outside, so 2, and then the 2 that has to stay inside. So x is equal to plus or minus 2 square root of 2. In B, we have negative 5x squared plus 9 is equal to 0. So first, I would subtract the 9. And we get negative 5x squared is equal to negative 9. Then I would divide the negative 5. So at the moment, what we have is x squared is equal, now we have a negative divided by a negative, so that makes it a positive 9 over 5. And now I would square root both sides. And here we have the square root of a fraction. So remember that x is equal to plus or minus, because I just square rooted, the square root of the numerator over the square root of the denominator. Now I know the square root of 9. The square root of 9 is 3. And I'm going to put it over the square root of 5, since I don't know what the square root of 5 is. Now remember, in the previous slide, we are not allowed to have a square root in the denominator. So I'm going to multiply the square root of 5 to both the numerator and the denominator. And so my final answer would be plus or minus. Now 3 times the square root of 5, I cannot multiply those together. Like I cannot do the square root of 15 because 3 is outside of the square root where 5 is not. So when we multiply them, we would just write 3 square root of 5. Basically, just put them together. Then the square root of 5 times the square root of 5 is the square root of 25, which is 5. So this would be my final answer. For x squared minus 24 is equal to 0. You would add the 24 over to the other side because we're trying to isolate the x. And we get x squared is equal to 24. Finally, you would square root both sides. So now we get x is equal to plus or minus the square root of 24. And just like with the other problems, we're going to try to simplify this square root. 24 is when you multiply 4 and 6. And 4 can be broken down to 2 and 2. So here we have a pair, and the 6 stays by itself. So my final answer would be x equals plus or minus the 2 that gets to go outside, square root of 6 that has to stay inside. Now I want to make a note when we are simplifying square roots, and I'm going to do this in a different color so we don't get confused. There are obviously multiple pairs that would multiply to give me 24. We could have used 4 and 6 like I did. We could have used 8 and 3. We could have used 12 and 2. It doesn't necessarily matter. Let's say if I use 8 and 3. 8 can be further broken down to 2 and 4. And then 4 is 2 and 2. So here's a pair. But this 2 and the 3 would have to stay inside. So when you have multiple numbers that either go outside or go inside, if they're separated, you can just multiply them together. So we have this 2 that goes outside, and on the inside, the 2 and the 3 would have to stay. So I would multiply 2 times 3, which would give me 6, and see how it would give me the same answer. So it doesn't matter which pair of numbers you decide to use, as long as they multiply to give you that 24 in this case, you'll be fine. Now let's look at this final example here. We have negative 4x squared plus 13. So first I would subtract the 13. And I get negative 4x squared is equal to negative 13. Then I would divide the negative 4. And I get that x squared is equal to a positive 13 over 4. Our final step is to square root both sides. So now what I have is x equals plus or minus. Now this is the square root of a fraction, so I can separate that. Square root of 13 over the square root of 4. Now I don't know what the square root of 13 is, and I can't simplify that, so I would leave that as the square root of 13. But I do know the square root of 4, which is 2. Now in this example, I don't have to rationalize like I did in B, and that's because I don't have a radical in the denominator. So this is an acceptable final answer. Now how do we apply these square root equations? There are two types of equations that are used most commonly with quadratics, which is for distance and height. So distance fallen in feet at time t in seconds is this equation. D of t, representing distance, is equal to 16 t squared, where t is the time in seconds. So if I ever want to know how far something has fallen, I can use this equation. And that's because the 16 represents the acceleration due to Earth's gravity in terms of feet. Now, if I want to know the particular height of something, so where it is at a particular moment in time, I would use this equation. H of t is equal to h0. This represents the initial height, so where your object started, minus 16t squared. So whenever you're working out a word problem that involves quadratics, you want to first determine which one of these equations are you going to use. Are you looking for the distance that the object has fallen, or are you looking for the height of that particular object? So here in this example, we have, if you drop a water balloon, how long does it take to fall 4 feet? Write your answer as a final statement. So here I am looking for how long. So I'm trying to solve for time. And does it take to fall 4 feet? This is the distance fallen. So this is d of t. So I would use the equation d of t is equal to 16t squared. Now I'm trying to solve for t, so I can't plug in anything for t. But I am told that d of t is equal to 4. So what I can do here is I can substitute d of t with 4. So my equation would be 4 is equal to 16t squared. And now I would divide the 16. So I get 1 over 4 is equal to t squared. And then I would square root both sides. So t is equal to plus or minus the square root of 1 over the square root of 4. The square root of 1 is 1, and the square root of 4 is 2. Now remember, whenever you square root, you always get plus or minus. However, this is a real-world application, and we have to determine, does it make sense for us to have positive time and negative time? And the answer to that is no, it doesn't. There is no such thing as negative time. Therefore, it takes half a second for the water balloon to fall 4 feet. And for all of these word problems, we're going to attempt to write a statement describing our answer. Let's look at a couple more examples. In this first one, we have on the moon, the distance d in feet that an object falls in time t in seconds is modeled by the function d of t is equal to 8 over 3 t squared. Suppose an astronaut on the moon drops a tool. How long does it take the tool to fall 4 feet? So keep in mind here that our equation for d of t has changed, and that's because the astronaut here is on the moon. Your distance, the equation for distance, depends on gravity. So if you're on the moon, the gravity is different on the moon than it is on Earth, which is why this equation has changed. So I have to evaluate what is my given information. Here I am told that we are looking for time. So I like to write like a little note here. So time, that's what I'm solving for. How long does it take the tool to fall 4 feet? That would be d of t is equal to 4. So that means that I can take my equation for d of t and I can substitute d of t with 4. So that means that 8 over 3 t squared is equal to 4. Now, if I want to cancel out this fraction, remember that we multiply by the reciprocal of that fraction. So I'm going to multiply both sides by 3 over 8 in order to cancel it out. So now what I have is t squared is equal to 4 times 3 over 8. And when we multiply numerator with numerator, denominator with denominator. 4 times 3 is 12, and 1 times 8 is 8. And we can simplify 12 over 8 to be 3 over 2. So now I have that t squared is equal to 3 over 2. And now I would square root both sides. Remember that I am solving for time here. So my answer is not going to be plus or minus because there's no such thing as negative time. We're just going to use the positive value. So what we have here is the square root of 3 divided by the square root of 2. Again, I cannot have a radical in the denominator, so I'm going to multiply square root of 2 over the square root of 2, which gives me the square root of 6 over the square root of 4, which is 2. So it takes the tool to square root of 6 over 2 seconds to fall 4 feet. But nobody talks like that, right? Nobody says, oh, it took square root of 6 over 2 seconds. So for these kinds of problems, we're actually going to put this in the calculator and evaluate for that decimal. So this is how you would do it. We would put here the square root of 6, and then we're going to divide by 2. And we get 1.2247, etc. We're just going to round to the nearest tenth. So it takes approximately 1.2 seconds for the tool to fall 4 feet. For this second example, the rooftop of a 5-story building is 50 feet above the ground. How long does it take a water balloon dropped from the rooftop to pass by a 3rd-story window at 24 feet? Now here, I'm not given distances, I'm given heights. I'm given that the water balloon starts at 50 feet above the ground. This is h0. This is the initial height of the water balloon. And we're trying to figure out how long, so I'm looking for time, for the water balloon to pass by the 3rd-story window, which is at 24 feet. This is the h of t, because that is the height of the water balloon. So what we do here now is we're going to use that equation from the previous slide, which is h of t is equal to h0 minus 16t squared. Remember, I'm solving for t, but I have h of 0, which is 50, and I have h of t, which is 24. So I'm just going to plug in those values. So 24 is equal to 50 minus 16t squared. And now I have my quadratic equation set up and I can solve. So first I would subtract this 50 over to the other side, and I get negative 26 is equal to negative 16t squared. And then I would divide this negative 16, and I get t squared is equal to 26 over 16. And finally, I would square root both sides. And now I get that t is equal to, remember, not plus or minus because there's no negative time, so square root of 26 over the square root of 16. Now I don't know the square root of 26, so I'm going to leave that as the square root of 26, but the square root of 16 is 4. Now in this case I don't have to rationalize because I don't have a radical in the denominator. So now to get the time, the approximate time, I'm going to actually put this in the calculator to get that decimal. So we have the square root of 26 divided by 4. And I get that the time is approximately 1.3 seconds. So it takes the water balloon approximately 1.3 seconds to pass by a 3rd-story window at 24 feet. Now you're going to see that when we start solving quadratic equations, and just like with absolute value and with all the other functions we've worked with, sometimes you get where you have no solution. And that is the same for quadratics. But the difference here is that when we end up with a no solution, it's actually an imaginary solution. And how that happens is when you end up with a negative inside of a square root. Now here's the thing, remember that the square root, so like let's say for example, the square root of -4. If I'm trying to figure out what two identical numbers multiply to give me -4, I can't, because the only two numbers that would multiply to, well, not the only, but let's say of a pair, would be 2 and -2. These are not identical numbers because one is positive and one is negative. Therefore, whenever you have a negative inside of a square root, what we end up with is the imaginary unit. So the imaginary unit is labeled as I for imaginary, and it represents the square root of -1. So if you were to square both sides, the square root would cancel with the exponent, and I get that I squared is equal to -1. So those are two important things to remember. I is equal to the square root of a negative, and I squared is equal to -1. So just so you know, when you're solving a square root, right, if you have the square root, let's say in this example, I put the square root of -6. The way that you would rewrite this would be to just make the negative positive and bring out the I. And so then the square root of -6 is I square root of 6. And I put here various ways of representing imaginary numbers that are all acceptable. You can either put -5i, I over 3, or you can separate it and put 1 over 3i, I square root of 2, I square root of 3 over 2, or square root of 3 over 2i. The I, think of it as kind of like another variable, but it represents an imaginary solution. So if we're going to simplify some of these square roots, if I have the square root of -68 and I want to simplify this using the imaginary unit I would make this positive and take out the I. And then we're going to try to break this down. Now 68 is when you multiply 4 with 17. And 4 can be broken down to 2 and 2. So here's a pair, and the 17, the only two numbers that multiply to give you 17 are 1 and 17. So that one will have to stay inside. So when I'm rewriting this radical, the 2 goes outside with the I. So this would be written as 2i square root of 17. Now, if you have -I square root of 2 squared, this is a monomial, meaning one term. So what we can do is just distribute the exponent to both parts of this term. So this is like saying -I squared times the square root of 2 squared. When you square any negative number, it makes it positive. So -I times -I is I squared. And the square root of 2 times the square root of 2, the square root just cancels out. So we get 2. Now remember that I squared is equal to -1. So I can substitute I squared with -1, and it's being multiplied with 2, which gives me the final answer of -2. For 2 square root of 18, square root of -18, remember we make this positive and bring out I. And I have at this moment 2i square root of 18. And now we're going to try to simplify the square root of 18. Two numbers that multiply to give me 18 are 9 and 2. And 9 can be broken down to 3 and 3. So this 3 can go outside and the 2 has to stay inside. Since it's going outside with the 2i, that's like saying 2i times 3, the 3 that gets to go outside, square root of 2. So my final answer here would be 6i square root of 2. In this final example here, we have the square root of 3 over 3i, and all of that is getting squared. So I'm going to apply this exponent to the numerator, to the denominator, and to the I. So this is like saying square root of 3 squared over 3 squared times I squared. And what that gives me when I work this out, this just cancels with this, so 3 over 3 squared, which is 9, and then I squared is -1. 3 over 9 can be simplified to 1/3, and 1/3 times -1 is -1/3. Now let's look at how this is applied with quadratic equations. If we're solving and we end up with an equation like x squared plus 12 is equal to 0, I don't know that I'm going to have imaginary solutions quite yet until I start working it out. Sometimes you do, sometimes you don't. So I'm going to subtract the 12, and I get x squared is equal to negative 12. When I square root now, I see that I am square rooting a negative number. This means that I am going to have an imaginary solution. So x is equal to plus or minus. Remember, we're going back to the plus or minus now because there's no context here, so we have to account for both solutions. The square root of negative 12. Now, just like I told you guys before, if you see a negative inside of a radical, just make it positive and bring out I. And now we're going to try to simplify 12. 12 is when you multiply 4 and 3. And 4, of course, is 2 and 2. So this 2 will go outside, the 3 will stay inside. So my final answer would be x equals plus or minus 2I square root 3. Let's try it with 4x squared plus 11 is equal to 6. First, I would subtract the 11. And I get 4x squared is equal to negative 5. Next, I would divide the 4. And so now I have x squared is equal to negative 5 over 4. When I square root, I see I have a negative inside the radical. So I know that I'm going to have to first make it positive and bring out I. So remember, we have x equals plus or minus I. And then the square root of 5 over 4 is the same as the square root of 5 over the square root of 4, which I don't know the square root of 5, but I do know the square root of 4. So my final answer here would be plus or minus I square root of 5 over 2. For 1/4 x squared plus 9 is equal to 0. First, I would subtract the 9. And we get 1 over 4 x squared is equal to negative 9. To cancel out this fraction, we would multiply by 4. So now I have x squared is equal to negative 36. And when I square root both sides, I get x is equal to plus or minus. I have to make this positive and bring out I. And the square root of 36 is just 6. So that means that the square root is completely gone since I know the square root of 36. So that would mean that we have 6 times I, which is 6I. In this final example, we have negative 5x squared plus 3 is equal to 10. So first, I would subtract the 3. And I have negative 5x squared is equal to 7. Then I would divide this negative 5. And now I have that x squared is equal to negative 7 over 5. Of course, last step would be to square root both sides. And again, I have a negative inside of the radical, meaning that I'm going to make it positive and bring out I. So I have I square root of 7 over the square root of 5. Remember that even though this is an imaginary number, I cannot have that radical in the denominator. So I'm going to multiply by the square root of 5 to both the numerator and the denominator. And this would give me plus or minus I square root of 7 times the square root of 5 is the square root of 35 over square root of 5 times the square root of 5 is the square root of 25, which is just 5. So this would be my final answer. And that's how you solve quadratics by taking square roots.